So these active devices are those which consume power, and typically this power is going to be in the form of DC, yeah, some kind of a direct current supply that does not change with time, and it makes use of that power for its operation. So all these devices are going to be powered. Yeah, they would need a battery or they would need some kind of a power supply to work, unlike a filter or a circulator or other passive devices. The first active device that we will focus on is called as an RF amplifier. The amplifier, as the name says, is used to boost a signal, to increase the power in a certain signal. So it's a two-port device. There is a certain input and certain output. So certainly the output power is going to be much higher. The output power is going to be much higher than the input power. So that's why it's an amplifier. That's the role of the amplifier. So it is denoted by the symbol that you see here, and often it's given the name PA, which means it's a power amplifier, which is used in the transmit side. A power amplifier will have a very high power output. On the receive side, you will also have an amplifier, but that's called as a low noise amplifier. Low noise. This is RX. So while you're transmitting, you're going to be transmitting very high power. So that's a power amplifier. And while receiving, you're going to be receiving very weak signal. That's going to be very low power. So in that case, you will need something called as low noise amplifier, because your signal is somehow cluttered with the background noise. So you need to partially select that particular frequency of interest without adding further noise. So here the objective is to reject noise, whereas here the objective is to boost power. So PA will boost power, whereas a low noise amplifier will reject noise. Yeah. For the entire communication system to work, not only should your transmit be able to power sufficient power to transmit, the receiver should be able to be sensitive enough to receive at a certain distance D, so that we call that the range. At that distance, it should still be able to receive the signal and process it for the communication to happen. So how much should be the transmit power? How much should be the receive power for a certain distance D is all what is determined by what is called as the link budget. So that determines really what will be the range of in which that particular signal will penetrate. For example, in a cellular environment, you might see 3 bars very close to the base station, but as you move away your cell phone, you go further away, the number of bars go down, because there is going to be path loss. Because the path loss, the signal strength goes down. But then, even if it is a single bar, the phone's receiver must have the sensitivity, sufficient receiver sensitivity, to be able to demodulate the signal and be able to establish the communication link. For example, a Bluetooth receiver, while the transmit power is pretty high, 0 dBm, dBm means 1 milliwatt, and the receiver sensitivity is negative minus 60 dBm. That means it's a million times less than 1 milliwatt. Minus 60 dBm, it should still be able to receive that and selectively amplify it so that you are able to subsequently receive the signal that has been sent. So it would have to have a gain of 60 dB prior to down conversion. Yeah. So that is minus 60 dBm becomes around 0 dBm. So in essence, that's what an amplifier is going to do. If you have, this is in the time domain, this is in time, this is in frequency. So you have a particular sinusoidal signal. That means, let's say at 2 gigahertz, you have a certain signal. So viewed in time and in frequency. You send that as an input, that's the P in. What the amplifier does is going to increase its amplitude. For example, in this case, the 1 has become 2. So it has a gain of 3 dB. Why a gain of 3 dB? Because it's twice. Output is 2 times the input. So you can go ahead and define the so-called factor beta, which is essentially the factor by which the input is scaled at the output. Yeah. So that's what is called as the linear gain. So you can view it in time domain or more conveniently in the frequency domain, so that the output is simply the product of the frequency response of the amplifier times the spectrum of the input. So G of F is the frequency response of the amplifier.